Hello guys, so in this quick video I'm gonna show you how to plot or sketch the output or the outputs, okay, signals of a diode clipping circuits, okay. Basically, usually for a simple circuit like this one here, we have the voltage across the resistor and the output, which is VB plus VD, okay, and of course the input, which is usually given like this. So in that, it is triangular wave. Basically, if it is, something not curvy, like the sine wave here, usually it's very easy to draw it, in a very beautiful way or in PowerPoint. Okay, so in that example here, okay, which is example of the lecture, we have, the same circuit, but the input was sinusoidal. Here, the input has some, similar characteristic like the sinusoidal. I mean, V maximum is and minus V maximum are the same, but it's a triangular wave. Okay, and we said that when we solved this circuit, we didn't care about the input shape. We just care about what is the input minimum, the minimum input here, at which the diode will turn on. Okay, and have the 0.7. And we said that this V input minimum, the minimum input at which the input will work, is basically the clipping or the clipping point at which the clipping will happen. Okay, so in that example that we solved in the lecture, VB was 1.4, okay, and VD on was 0.7. So clipping happened at 2.1, which is this value here, 2.1. In that example, I just made very small or minor change. I make VB equal to 1.3 so that the addition will be 2, not 2.1. That's will make it very clear for you. Usually decimal places is not good. Okay, so what we're gonna do? So basically, we're gonna have exactly the same outputs, except that the value at which the clipping happen is 2, not 2.1. Okay, so basically we will have something similar for the output here, and something I mean for this one, we're gonna have something very similar here in the output, and for VR, which is this one, we're gonna have again something very similar here. Okay, so let's do that. So the first thing you do, you take just one of them, either V output and VO or VR, whatever you choose. Of course, basically you solve this first on a piece of paper using paper and a pen. Then based on the output, let's assume that this is your solution. Okay, and we're gonna draw it here using PowerPoint. So let's start, for example, by VO. So looks like VO is exactly the same as that guy, except for this red dome here. Okay, and you can go to the lecture and you're gonna have my proof why this is exactly this one, except for this dome proof. First, locate the clipping point. Okay, so this is just a sketch. You don't care about much about when exactly I should put this point, because this is basically 20, and this is the input means just 2, so it's 1 to 10. So it's very smooth. Maybe here if we draw to scale, but since this is just a sketch, I want to show you that I want to show, or that there will be a clipping. Okay, so we just don't care much about the scale here. So first we locate this point. So then I can have a copy of this line here, dotted line, and choose any point between V maximum and the 0. This is a 0, for example here. Okay, so and we're gonna name this V input minimum, which is the clipping point or the clipping voltage. V input minimum. Okay, and we can of course increase the width of this so that you don't have 2 lines here. Okay, then basically you take a copy of that dotted line and mark these points like this. Another copy, because these are the important points at which determine the shape of this guy and the shape of this guy. Just like what we did here. If you notice, there is a small dotted lines everywhere. I made for you the dotted line for the Vmax minus Vmax, and we just need more lines for the intersection of the input minimum with the signal. Then you can copy both together and put them here. Okay, good. Now the second thing to do is to draw this one. To draw this one, we need to clip here. So basically, first to do, copy just the whole triangular wave of the V input here and put it here in the VO. And try to align it, so that, yeah, that's good. Okay, but this is wrong. Still, we need to, remove this red. So you make a copy again of this horizontal line and go to the intersection between V input minimum and that one. So this is basically the same as this one. So again, V input minimum here. Now we want to remove that part, the upper part here, okay? So we can zoom in like this. Then we highlight that guy and just reduce like this. Very simple. Again, for that one. Yeah, that's good enough. Now we need to, tie these together. So we need another line. So go to shapes here and, choose this guy and connect them together. We can also zoom to make it better clear. And also you can highlight this, then go to the home and the brush so that the new line will have the same characteristics as the old ones. Okay? Yeah, it's good enough. It's good enough. Okay, guys? And of course, don't forget to do the same here. So we can here just copy like this and paste here. Then we zoom in and reduce the length of that line again like this. And from this side as well. And here it is. This is basically, VO. Now we want to do VR. I think, you got the idea. It should be also be. So we're going to first again. Now we don't need, the negative portion because there is no negative here. So just copy, the positive portion for VR. So we copy it like this and we place it, like this here. Okay. Now we need again this, this, it's the upper part from here, which is really, a little bit confusing, but we can do it in a very easy way. So what you're gonna do, just zoom in like this and, reduce, oh yes. So basically a good thing is to locate the intersection. So, I mean the input minimum, the input is a point of clipping, which should be that point. That's actually very important step. So when you try to decrease the length, you know exactly which point you're gonna go. Okay. So that part now is if we put that part on top of that one here, we should get exactly, that one. Okay. Which is really nice. I'm gonna show you that now after doing that. So, and please change the color. So let's make, for example, let's make this color, for example, red or something. Red. Okay. Now after doing that, remember this is not the right one because the right one should be go down to the x-axis. So time axis here. So we make it like this. Okay. Now, no need basically for that one. You can just copy, just, yes. Now we move it using the arrow, the left arrow, until it, hangs there here. Okay. Yeah, it should be correct. Then you remove the old one. Actually, we don't need it. Okay. Let's now make this guy, with a different color. And you should do that as well in your homework. Okay, let's do it with green, for example. Oh, this color is really nice also. Okay, now the moment of truth. Again, this one, I mean this voltage VR plus this voltage V output should equal to input, right? So you can check for that in a very easy way. Just copy, oops, copy this guy and paste it here. What you're gonna get is exactly, I'm sorry. So it looks like we go to the another, yeah. So what you get should be exactly the same as, the input, okay? And this is Kirchhoff, and Kirchhoff is a fact, it all, it must be satisfied all the time, okay? But of course, this is for you to check. I mean, in the homework, I just need these without, I just need this final drawing. But I'm telling you that if you want to check if you're right or wrong, if your drawing is right or wrong, just add the input to VR. They should, in that way. I just show you, just copy VR and paste it on top of V. You do the opposite. You can copy VO and paste it, over the drawing of VR here. Okay, and you should get what? You should get the input, exactly the triangular wave. Okay. Okay, guys, this is basically how to draw or plot the outputs or the voltage of the clipping circuit using PowerPoint. Thank you very much and good luck in your homework. Bye-bye.